All right, I guess welcome to class. This is kind of weird, but here we go. So first of all, let's see. Got 1, 2, 3, 9 people here. Welcome, welcome. And what are we doing today? So have you guys had? So first of all, gosh, let's look at all the things we have here. I think you can. I thought they enabled some things. Sorry, 11 participants. Cool. Okay. So obviously I'm a little new to all this. I've sent you all quite a few. Gosh, I've got these headphones in and it feels like it makes it weird to hear what I'm saying. So I think I'm gonna take them out because I don't really need them. Let's see, let's change the volume. So not that you guys have to talk, but if you wanted to talk, you're certainly welcome to. And I'm looking at the chat, so if you have questions, you want to text them or chat them to me, I can see those. I thought I had enabled some like hand raising functionality, but I'm not seeing that right now. Does anybody see like over underneath what the chat would be, the ability to raise your hand or ask me to speed up? That's a good question. Has Sandra sent a link to the Zoom? I don't know. I've seen his Canvas page. It looks like there's not a ton of information on there just yet. So let's see. I had an agenda of a few things I wanted to cover, but again, I don't think we're going to do much math today because we're kind of just getting started. Oh, there's an option to clap and raise. Okay, but there's no like speed up or slow down kind of option, Genevieve. I'll fix that for next time. There is an option to like do other things, I think. Not a big deal today. So first of all, let's see, where is my list of things? I had a list. It's on my computer somewhere, as is everything. Here it is. Where'd you go, list? Sorry, all my stuff is oh, it's over here, okay. We've got many, many screens. So, oh yes, as a reminder, I'll be recording the Zoom meetings so that you can look at them later. I don't imagine this one will have a lot of use later, but you never know. I wanted to ask everybody, so I assume you all had to register and log in for this. If you wanted to say yes or no, I think it should be yes because I said a password. All of you should have had to do that. And I imagine I will get a report later about who, what am I trying to say, about who has attended. I can see that there are, let's see, 12, 13, 14, 13 people here, which is great. What else? So I say a lot. I will try not to say too much, but you know, it gets, when you're trying to think of what to say, sometimes you just kind of go there. A few things you have probably heard already, but just want to make sure you know. For your 17A class, for all your classes, pass no pass grading, you can change, you can either opt into pass no pass or opt out of pass no pass up until the last day of instruction, which is June 4th. So if you feel like you're just barely going to pass, but or even if you're not going to pass, nothing about that, but it might be worth exercising that option, and that won't count towards your overall number of units that you're allowed to take pass no pass at UC Davis in general. I also want to remind you all, not that this necessarily applies to you since you are all here and attending a class this quarter, but if for some reason you decide within the next couple of days that you maybe don't feel like attending UC Davis this quarter, you still not too late to PELP, which is the Planned Educational Leave Program. If you want more information about that, I did send you guys an email, I think right before spring break started, or maybe during finals. So if that's something you're thinking about, just be aware that it is an option. What else do I have on here? Not a whole lot. So can you, so there isn't like a raise your hand option, is there? So does everybody have the chat up? Respond yes to the chat. Cool. All right. It looks like just about everybody. So you're welcome to ask questions there. And I don't know. So let me see. Do you have the option to unmute yourself if you want to? Okay, great. So not that everybody wants to talk over Zoom because it feels kind of weird, I gotta say. But if you wanted to ask a question that was easier asked than written, you are certainly welcome to chime in. Don't feel like I have to be the one talking here all the time. Let's see, I'm trying to close a few things here. So, oh, I know what I wanted to ask. So is anyone in FAM's class? I don't think anyone is because the class was scheduled at the time where it would conflict with FAM's class, but I just want to make sure that there was no one in FAM. All right, that looks like a resounding no. So we will stick with what Sanders is doing, which will be challenging at first because, again, he hasn't posted a whole lot of information. Let's see, what do I want to see here about him? Where'd you go? Sorry, just 1 second here. I'm looking at his canvas, which doesn't seem to have a whole lot. He's got the syllabus on there. He's got his Piazza information on there. He's got his office hour times on there. And that seems like about it so far. Yeah, no real grading information. He's got a Zoom link on Canvas. And then it directs you to open a new window. And it looks like that might take you to his Zoom meeting. It doesn't have any upcoming meetings on it. Oh, he said to use Aggie Video? Okay. So I'm not familiar with Aggie Video. I'll check that out later. But that's what we've got. So I imagine you guys probably don't have a lot of questions today because, well, you haven't even had class yet. I'm a little, what's the word I'm looking for? I don't know. You know, a little flummoxed. This is new for everybody. I posted on the co-class Canvas page in the module, I posted some graph paper that you might find useful if you have the ability to either draw on it with a stylus or print it out and draw on it. It's some log linear and log log graph paper. Yeah, oh, Aggie Video is kind of weird. Well, great. I will check it out then. So, I mean, it's the beginning, I guess. Let's take a look here. So I was looking at the stuff from FAM's class because he's actually posted a lot more material. And I might as well I'll post his handout on Canvas as well so that you guys can have access to it. It's basically a lot of pre-calculus stuff, kind of going over a lot of different graphs and things. Yeah, I think that's a good idea. Ask someone for the link to class today. Yeah, that's what I would do. Because I do not have it. So I'm trying to think, like, we could do some, oh, I have my notes here. Questions. So I guess I should ask, do you guys have any questions? Like, is there anything about this class that I might be able to answer for you before we get going and maybe start talking about some math? Workload units, sure. Workload units are pretty straightforward. They count towards being a full-time student. So that means they count towards, having the minimum progress. I think it's either 12 or 13 units a quarter. I don't remember exactly. They count towards that. They count towards that for financial aid, but they don't count towards graduation. So the 1 unit you'll get here will count towards being full-time, but it won't count towards the 180 unit total you need to graduate at the end of 4 or 5 years. Is there anything you should practice? Yeah, there's definitely stuff you should practice. I've got a few ideas of things. In fact, might as well do, sure, we can do some math. I like doing some math. So I'm gonna write on the whiteboard to see how that goes, and you guys can let me know how you can see it. Now, I think, let me change, yeah, so if you change it to, ooh, Genevieve, are you saying something? Or is it just big because I don't know why? I'm trying to see myself big, but maybe it doesn't let me do that. Let's see here. Sorry, you guys are my guinea pigs because this is the first class I'm doing. I can do the gallery view. There's some way to like, I know I said this before via email that you can like pin my video. I don't see how to do that because I am me and not you. So, oh, look. So when I clicked on manage participants, I see that there are things that you can do, like say yes or no, or go slower or go faster. So maybe if you click on that thing at the bottom of your Zoom, you can see those options. There's also a thumbs up, thumbs down, hand clap option, and also a need a break and a away option. So you might look at that. I'm sure we'll all be Zoom pros by the end of the week. Maybe you already are. But yeah, I don't see. Oh, there's also the reactions where you can give a thumbs up or a hand clap. Not that you need to pat my back, but just want to let you know all the things. Oh, there's a new message. Sorry, I should look at that. Maybe we need to access. Maybe we need. Yeah, you might. I thought I'd set the permissions so you can have them. Oh, you can see it. So how did you get there, Natalie? You feel free to type it or to talk if you want to talk. There's also lots of video settings if you guys want to change things around. You can do weird stuff and have like a fun virtual background, which apparently a Weezer band of old people set it up. So look, ooh, virtual background, super fun and not useful for writing. Oh, it makes my fingers look weird though. So anyway, no virtual backgrounds for me. Oh, I did. Yeah, the more exactly. Good job. I also do want to point out I will also be using the document camera on occasion, which is pretty useful. And depending on what feedback I get, I may use that more than the whiteboard because it might be my writing. There's kind of too much distance here between me. So I'm going to go off camera here for a sec. And oh, there's the whiteboard. That's from 17C. So let me ask you guys, how easy is it to read this? Do I need to write bigger? Or does that seem all right? That's good. A tiny bit bigger? A bit bigger? Okay, I can try to write bigger. You guys might need to remind me. As any of you that have had me before, you know that my writing is not the best, but I'm going to work on it. So yeah, let's go check out let's go back. So let's see, I'm going to go back to the FaceTime camera. Cool. All right, so let's try writing on the whiteboard and see how that looks. We might as well do some math because, right. So let's see, the whiteboard, I can move, actually, let's get my screen up a little bit higher because that might be good. And let's move it a little bit closer. Sorry. I'm exactly right here. That can be closer even. Yeah, that looks good. That's gonna be too close when I'm sitting down. But I think you guys can see that all right? Yeah. So we lock these wheels in. Okay. Yeah, it's kind of huge. Also, my screen kind of reflects on that. Let's see, I can't really do anything, but I can close this. It makes it a little less terrible. Yeah, but I need to change like the background on my screen so it's not quite so reflective. Let's see, I had something here I was gonna look at. There we go, I want that, let's put it over here. Can I put it over there? There we go, sure. So yeah, graphing stuff, my graphing is not gonna be great. Let's talk a little bit about domain, and then we'll talk a little bit about some difference quotient stuff because I think that might be worthwhile. And then off so you're not gonna see my eyes, oh well. You're missing out. Maybe if I stand by here, hey, you can kind of see me. It doesn't look super duper awkward. So let's talk about, let's see, I want to find the domain. We'll actually talk about the three kind of standard domain examples. And then we will do some difference quotient stuff because that's definitely going to come up. So let's look at this function. Let's say our function is f of x equal to 7x plus 2 over x squared minus 3x minus 10. Sure. So in this, so first of all, how does that look? Is it pretty easy to see? Awesome. I'm going to try different pen colors too. I've heard the orange color pen is not great, although one person said they thought it looked really good, so who knows. But we'll try the blue one, then we'll try other ones on the next one. So how do we find the domain of this? Well, for a rational function like this, where we have a denominator, we have to make sure that the denominator isn't ever equal to 0. So we're going to exclude where x squared minus 3x minus 10 is equal to 0. So we're going to factor if we can. If we couldn't factor this quadratic, we'd use the quadratic formula. This one's definitely factorable. So we're going to have, I wonder if there's a way I can put the chat somewhere like where. So just, you guys are the guinea pigs. So I'm just thinking here, right? Like I'm looking at the board, I have to look back at the chat, but I guess that's true in class too. I actually have to look at you guys. But if you want to stop me and I'm not looking at you, you might have to actually talk and unmute yourself. Because I don't think, there might be another way you can make noise by raising your hand or something, but I'm not sure about that. So if you need to get my attention, do something. So I'm going to factor this. It factors as x minus 5 times x plus 2. And so then we see that x equal to positive 5 and x equal to negative 2 are the numbers we want to exclude from the domain. So some people just write it as like x not equal to 5, x not equal to negative 2. That's fine-ish, but most people are going to prefer that you write it using interval notation. So the way we actually write the domain here is by saying, okay, I want everything from negative infinity to negative 2 exclusive, use a parenthesis. And then everything from negative 2 to 5, again, exclusive, use parentheses. And then finally, everything from 5 to infinity. And that's what the domain of this function would be. Let me ask you guys, are you seeing glare right around here or not really? Is that just me? Glare, yes, no? Just a little? Okay, cool. I won't worry about it. If I need to fix it, I can just change the background on my computer to something really dark. So let's be smart, meaning let's James be smart. This thing is really, sorry, one sec. Oh my God, this thing is so tight on here. I thought I used a wrench earlier to make it untight, but I guess it got tightened again. There we go. Okay, come on. Yeah, all right. All right, good. Cool. So let's try green. So let's find the domain of this function, g of x equal to, let's do a square root. Square root of x cubed minus 6x squared plus 9x. First of all, how's the green look? Not as good as the blue? Okay, I like the thumbs up. Thumbs up is good. Yeah, cool. All right, fine. Fair enough. So let's see. One thing I want to say. No, I'm not. So for a square root, so unlike the previous problem where you can't divide by 0, so we just exclude all the single points where the denominator is 0. Here we're going to exclude the whole interval of numbers because we're going to have to exclude everything that makes the denominator, sorry, not the denominator, the part underneath the radical negative. So we need x cubed minus 6x squared plus 9x to be greater than or equal to 0. Whenever you have a square root or a fourth root or any even root, we have to say that everything inside the even root is non-negative. And then again, if we can factor, we're going to factor. We can. First, I can factor out an x. it's kind of weird, like whoops, and in fact, I'm talking to myself essentially. I know you guys are there and listening, but not having seems like stay so back to me. Not that I'm saying you need to, it's just I'm gonna have to get used to just talking to the air. So we need this to be greater than or equal to 0. And then we can factor this further. I've got x times x minus 3 times another x minus 3 times x minus 3 squared, greater than or equal to 0. And once we've got this inequality, this one side 0 and the other side factored as much as possible, then we're going to use the number line and put the things that make it equal to 0. So the zeros here are x equal to 0 and x equal to 3. So those are the numbers that are going to go on the number line. So over here, I've got 0 and 3. I'm trying to see if this whole expression is positive or negative in the 1, 2, 3 different sections of the number line. So first I pick a number larger than 3. You can pick 4, you can pick 4 million, it doesn't matter as long as it's bigger than 3. So pick a number greater than 3, like 4. If you plug in 4, this part's positive, and this part's positive, and its square root is really positive, and positive times positive is still positive. Great. Then you can either do something we learned in pre-calculus and pre-16A or whatever pre-calculus class I've taken. So the 3 comes from this factor here. This factor has an even multiplicity or even power, which means the sign's going to stay the same. It's kind of like, in fact, it's exactly like if you're graphing this, how the x-intercept at x equal 3 would bounce off the graph. In fact, I'll probably graph it afterward. You could also check a point. Pick something between 0 and 3, like 1. Plug it in. 1 is positive. 1 minus 3 is negative, but the negative number squared, the evenness is changing that negative thing to still be positive. It's positive there. Then we can do the same sort of thing on the other side of 0. We can either say, well, 0 came from this factor here. It has an odd power of 1, meaning the sign is going to change from positive to negative. Or if you wanted to, you could say, pick a point like -2. -2 here is negative. -2 minus 3 is negative, but the negative number squared is positive. So a negative times a positive is negative overall. All right, so we've got the whole number line classified. Now we just want to pick the parts we want. We want the parts where it's greater than or equal to 0. So I want all the positive parts. And I also want the parts where it's equal to 0, which are these points here. If you plug in 0, it's equal to 0. If you plug in 3, it's equal to 0. So our domain here, now, the right way to write this is starting at 0 and there's no stopping. So I just want everything from 0 to infinity. I've definitely seen people break it up from 0 to 3 with brackets and then from a bracket 3 to infinity with a parenthesis. And while that's not wrong, it's not as right as it should be. So if there's no parts where you're like stopping or taking a point out, you should write it as one whole interval. Questions about that? Oh, I was going to do the graph too. So while we're at it, we might as well do the graph. Let's do the graph in red. See how red looks. So on my graph, I would do something, and I'm not going to write it all down because so I find the y-intercept by finding x equal to, or setting x equal to 0. G of 0 is going to be 0, right? Just plug in. Oh, sorry. I don't want to graph this really. I forgot about the square roots. If I was just graphing x cubed minus 6, yeah, so sorry about that. Whoops. I really just want to look, I wanted to look at the graph and just the inside part to kind of show you how this positive, negative thing works. So let's actually just look at this other related graph. X cubed minus 6x squared plus 9x. Or if you prefer, x times x minus 3 squared. I'm just going to go through it quickly. The y-intercept would be 0. If you plug in 0 for x, you get 0 for y. The x-intercept would be 0 and 3. And then if you remember about n behavior, this polynomial, x cubed minus 6x squared plus 9x, has degree 3 and has a positive leading coefficient, meaning it's opposite, right? One side's up, One side's up, one side's down. Oh, sorry, my picture doesn't look. I'm gonna change that picture back to being mirrored because it looks so weird to me to see myself not like reflective. Sorry, set. Mirror me. Yeah, cool. Good, great. That doesn't change it for you guys, so everything's fine. So when the degree is odd, one side's up and one side's down, and when the leading coefficient is positive, it's the right side that's up. So let me ask you guys, when I do this, is it showing you your right or your left? Okay, good. So just like normally I would have to raise my left hand to be like, that's the right way. Okay. So we'd start down on the left, up on the right. So we'd come this way. Whoops, my graph's not gonna look great here. Sorry. Start here. We're gonna go through this x-intercept because it has an odd multiplicity. And then we're gonna come and we're gonna bounce off this x-intercept because it has an even multiplicity, which is exactly why it's positive, right? Positive, positive, negative. That's what's happening there. That's how I was using the multiplicity of each of the intercepts to figure out if it's positive or negative. So that's kind of a very basic square root or even root kind of domain problem. You set the insides to be greater than or equal to 0, and then you try and solve their inequality. Let's do one more problem that's going to be similar. Let's see. Yeah. So let me ask you guys, I don't love how close this board is. I'm going to, not because it's not a good picture, but because it's not a lot of space for me in here. So let's see if I back it up a little bit. Back it up. Is that still pretty easy to read, or is it noticeably worse? Good. All right, cool. Let's see. I've got more pens here. One sec. Let's test that. So I assume the red pen was fine. Yes. Now you can give me a thumbs up or a thumbs down. There's a thumbs down option, right? Yes, there is. Okay. Yeah. Cool. So let's do one more, and then we'll talk about kind of the usual stuff. Hope you all are doing well, by the way. It's kind of a weird world we're living in these days, being all at home. Wow, this thing just wants to get really tight. Interesting. I think it depends on which way. Okay. All right. So how about this function? H of x equal to the log base 3 of x minus 4 cubed times x plus 2 to the second times x minus plus 5 to the fifth. How's the orange pen? Thumbs up, thumbs down. All right, I'm only seeing thumbs up so far, which is fine. Just want to make sure that it's really fine. I did get some feedback from some of my coworkers that it was hard to see. All right, so moving on to this problem. This is actually very similar to the problem we just did. Is the first one x minus 4? Yes, that is an x minus 4. Yeah. This is the log base 3 of x minus 4 cubed times x plus 2 squared times x plus 5 to the fifth. So, what time is it? Oh, plenty of time. I do have a meeting right after this. I have to make sure I end like on time to the next meeting. I know I have to go super far. So, logarithm domain problems are very similar to square root domain problems in that you're going to set all of the stuff inside the function, whether it's inside the logarithm or inside the square root, to be something. In the previous, square root problem is greater than or equal to 0 because we can take the square root of 0. Square root of 0 is 0. Just like the square root of 1 is 1. For a logarithm, you can't take a log of 0. So here we have to set the insides, x minus 4 cubed times x plus 2 squared times x plus 5 to the fifth to be greater than 0. greater than, not equal to 0, strictly greater than 0. And then we're going to do the same sort of thing we did in the previous problem. We're going to make a number line. And on that number line are going to go all the zeros of this left-hand side. It is important when you do these, when you're solving these domain problems, if you're trying to solve this, you have a 0 on one side and everything else on the other side, so that you can factor this if it's not already factored for you. Yes, only for log greater than 0. For square roots, it's going to be greater than or equal to 0 because you can take the square root of 0, but we can't take the log of a 0. And if you remember, I'm going to draw over here real quick, kind of a small graph. That's the point 1, 0 here. This is the graph of any logarithmic function, really. I'm going to say this is y equal to log base. You can pick any base. I'm going to say log base 3 of x. So a logarithmic function has a vertical asymptote at 0. You can't plug in 0. You can plug in really, really, really small positive numbers like 1/1000th, 1/1,000,000th, etc. And the values that are output get more and more negative, but you can't actually input 0 into a logarithmic function. It's not in the domain. We also do it if it is in the denominator. Well, so what do you mean if what's in the denominator, Genevieve? Like if you have a square root, or I'm not sure what you're saying exactly. I'm going to continue on with this, but if I see more.
If we have a polynomial, we would make sure that it couldn't equal 0.
So this is why you have to say the log has to be greater than 0. And we'll come back to them. So the zeros here, the things that make this left side equal to 0 are +4, -2, and -5. We need to make sure that we put those in the right order. So +4 is over here, -2, -5. I don't really care about the spacing at all. I'm just trying to put them in the right order. I usually start on the right, although you can really start anywhere. I pick a number larger than 4, like 5 for the unexciting, or a bajillion. I plug in the bajillion, this is positive, this is positive, this is positive, the whole thing's positive. I personally like doing the thing where I look at the powers. So 4 came from this factor with an odd power meaning the sign is going to change. -2 came from this, which has an even power, meaning the sign is going to stay the same. -5 came from this factor with an odd power, meaning the sign is going to change. You can also plug in points. I could plug in 0 here and say that this is negative, this is positive, and this is positive, and then negative times a positive is positive, negative. I can plug in -4 here. -4 minus 4 is negative. 2 and odd power is still negative. -4 plus 2 is negative, but it's squared, so it's positive. So we have a negative, a positive, -4 plus 5 is positive. So it's negative times positive, which is negative. And then I can put something like -6 over here, and -6 minus 4 is negative, cubed is still negative. This part's going to be positive always because of the even power. This part now is going to be -6 plus 5 is -1. -1 to the 5th is still negative. It's a negative times a positive times a negative, which is positive overall. Okay, so now we have to pick the parts we want. I want this part and this part. So my domain here, oh, and I do not want any of the endpoints, right? I don't want -5, I don't want -2, I don't want +4. So I want everything from -infinity up to -5, exclusive of -5, but we don't want -5, it's not in the domain. If you plug in -5, we have 0 here, and 0 times this stuff is still 0, and log of 0 we can't do. That's why we don't want the -5. And then we also want, so we use a union symbol, everything from 4 to infinity, again, exclusive of 4. All right, so let's sum up, and then we'll do a couple problems, and then we'll also, there was something else I mentioned that I wanted to talk about. Now I have totally forgotten. It'll come back to me in a second. It's kind of fun. Kind of. So, yeah. Oh, it was different switches stuff. Yeah, I remember. This board's kind of warped over here. Stole this board from the library, and by steal I mean we own them and I borrowed it, so I didn't really steal it. Where did the pen go? So here are the general domain guidelines. There's three things. First, if your function is I don't really care what's on top, over some stuff, right? I don't care what's up here. Then the thing we're going to do is we're going to say, okay, we're going to set the stuff equal to 0, and then we're going to exclude just those numbers, or exclude the solutions. The second thing we saw is if your function is the square root of some stuff. And it can actually be any even root. So it can be the square root, the fourth root, the sixth root, the eighth root, whatever. Or it can also be, sometimes we write roots this way. If it was, say, your stuff to the 1/4 power, that's the same as the 1/4 root, or the 1/6 power, or any fractional power where the denominator is even. You could even have a different top, right? You could have like a 3/8 power, and you would still have this domain restriction. You have to set the stuff to be greater than or equal to 0. Because it's okay to take the square root of 0 or the fourth root of 0, but you can't take the fourth root or the square root or any even of a negative number. Right? That's when you get imaginary outputs, which is something you talk about eventually in 17C, I think, where you have like imaginary numbers when you're, well, I don't want to say too much. There are complex or imaginary numbers eventually in our future. Finally, the third thing we saw is if your function is a logarithm, I'm going to say log base b, or b can be any normal number, usually a positive integer or the number e, right? E about 2.7. That's an important one. If you have a logarithm of some stuff, and in this case, we have to set the stuff to be strictly greater than 0. So that's the general kind of big picture for how we find the domain of various functions. Now, I think I know what Genevieve was asking with her comment, but I'm going to do an example that kind of combines a couple of these things. So I think if I go this way, yeah, that totally makes it tighter. Let me try going the other way. So I think I'd rather have to tighten it than have to really try to loosen it. Yeah, that seems good. Okay, cool. We'll get the hang of this. So maybe we'll get the hang of this. Come on. All right. Cool. Maybe cool. Yeah. Writing's fine. Erasing is kind of not the best. So here's something I think is an example that you were kind of thinking of. Let's say my function was 2/5 minus the square root of x plus 19. So this one kind of has two different pieces we have to consider. One piece we have to consider is the denominator is not allowed to equal 0. So we're going to set 5 minus the square root of x plus 19 equal to 0 and solve. Interesting. So to solve this, the easiest way to solve this is probably to add this over here. Say 5 is equal to the square root of x plus 19. And then square both sides. So we square both sides, we get 25 on the left, we get x plus 19 on the right. Subtracting 19 from both sides, 25 minus 19 is 6. Now, something to be aware of. When you square both sides of an equation, sometimes you get what are called extraneous solutions, meaning they're not actual solutions to the original equation. This isn't one of those. If you plug 6 back in, you totally, to the original equation, you definitely get a solution, right? 5 minus 6 plus 19 is 25 squared, 25 is 5, 5 minus 5 is 0. So this totally is a number we have to exclude. Exclude. There was something else to say here. Oh, but you could totally accidentally, like if instead it had been, instead our example had been this, 2 over 5 plus the square root of x plus 19, and we had set that denominator equal to 0, and brought over the 5 like that, and said square root of x plus 19 equals negative 5. There's no solution to that. Right? The square root never gives you a negative answer. If you square both sides, you'll get the same answers over here. Square this, you get x plus 19. Negative 5 squared is positive 25, and subtracting 19, x does equal 6. But if you look back here, if you plug it into the original, it's not actually a solution. You get 5 plus 5, which is not 0, it's 10. So just be careful. Sometimes you get weird extraneous solutions. The other thing we have to do here is we have to actually worry about the insides of the square roots being non-negative. So we also have to set x plus 19 to be greater than or equal to 0. Unfortunately, that's a really easy one to solve because it's just linear. We can just subtract 19 from both sides and say x is greater than or equal to negative 19. Which is pretty straightforward. There was something else to say here. Oh, and then we have to combine them all. And when I'm combining them all, I really feel like it's easiest if I just draw it on the number line. So here's my number line. I know I don't want 6, and well, I should start off. I know that negative 19 and 6 are the important numbers here. Go on my number. I don't want 0 unless it's actually a 0. So I just want 6 and negative 19. And then I want everything, so x is bigger than or equal to negative 19, so I want to include negative 19. And if I'm bigger than it, I want everything to the right. But I know I want to exclude 6, so I want an open circle here. I don't want that. But I want everything to the right of that too. So my domain here would be starting at negative 19 with a bracket to 6 with a parenthesis, and then everything from 6 forever onward to infinity. So are there questions about that? All right, I'm gonna move my board a little bit I'm still testing out. I'm trying to, I don't know how familiar you guys are with whiteboards, but they get like terrible black whiteboard dust everywhere. So I'm trying to like put this on my little carpet here, which I can then throw in the laundry after the end of the week. So I don't get my carpet super gross with whiteboard dust. So let me ask, can you still see this all right? Yes, sir. Cool. Okay, what time is it? Okay, we got like 5-ish minutes. So let me do one example of a difference quotient. Also, so I do plan on posting this video, but I've been hearing from my colleagues that it's taking a while for the video to be available from Zoom. So it might take a bit, but the plan is to post all these videos so they're available for you to look at later. My plan is also later today to record a few videos that are fairly short, probably like no longer than 10 minutes each, where I do more examples of things. So if you guys have, not that you've had class yet, but once you, what time is your class at actually? What time is Sanders' class? Anybody? You are allowed to talk if you want that. 1 to 2, okay, great. So if you, after Sanders' class, if you guys have any questions, feel free to shoot me an email or post something on Canvas as a discussion. at saying like, hey, we talked about this, and I would love some examples on that. That would be super helpful to me, and also I'm sure helpful to you. So if you are so inclined, please go ahead and let me know what you would like to see me talk about. The other thing I want to talk about is the difference quotient, which again, if you've been in pre-calculus before, you've definitely seen this already. So very generally, this is your difference quotient, f of x plus h minus f of x all over h. Now, there is a very important physical interpretation of this. The whole idea here is it's essentially the rate of change, or the average rate of change of a function between 2 points. You can also call it the slope. So a lot of people say, okay, well, I've got some function, and let's use some placeholders here. Let's say maybe here's my function. And here's my spot x, and here's my spot x plus h. If I look here, this is f of x. And this is f of x plus h. And this rise is f of x plus h minus f of x. And this run is x plus h minus x, which is just h. So the slope of the line connecting this point to that point, which I'm going to try and draw, wish me luck. That turned out all right. So the slope of that line is exactly the rise over the run when you go from this point to that point, which is exactly this quantity divided by this quantity. So for that line, or I should say for the secant line, that's what you call it when you connect 2 points on the graph like that. It's called the secant line. For the secant line, the slope is given by the difference quotient, which is exactly that right there. F of x plus h minus f of x all over h. Now, the reason we're talking about this is because the definition of the derivative heavily involves this particular expression. So when we're trying to calculate, or I should say, when we're trying to find derivatives using the long definition, not the shortcuts like the power rule or the chain rule or the product, which you're going to learn later, when you're very first talking about derivatives, this is kind of what we've got. So let's go back. Trying to be very conscientious about going back and forth. Okay. So one example, and then we'll call it a day. I'm going to do, let's do a slightly harder example. Sure. So let's say our function is f of x equal to, square root of, I don't have that much time. Let's just say 2x plus 3. So I want to find, now finding this is not too terrible. Right, just writing it down is like, okay, big deal. F of x plus h is the square root of 2 times, instead of x, I'm going to write whatever's in the parentheses, minus the square root of 2x plus 3. That's x plus h right there. And so here is your f of x plus h. Here's your f of x. And when we deal with this is by multiplying by what's called the conjugate. So I'm going to take that square root, I'm going to write this 2x plus 2h plus 3 minus square root of 2x plus 3 over h. I should back up a sec. It's easy to write down the difference quotient, but usually people want you to find the difference quotient. They want you to find and simplify it as much as possible. And when they say that, what they really mean is you have to cancel this bottom h out. Eventually, we should be able to make that cancel. So here we're going to do, we're going to multiply by the conjugate, which is the same as this part here, except with a different sign. So if the plus here with the minus there, the minus here with the plus there. Same stuff. I might have to just had her alarm go off for some reason. I don't know why. So again, we have to do the same stuff on top and bottom, right? Because we can't multiply anything other than 1. I know it's 1050, we're almost done. So if I multiply out the top, I get this times this. So when you multiply 2 squares together, you just get the insides. So I get 2x plus 2h plus 3. And now I'm not going to show all the work because we're out of time, but I get this times this minus this times this. And this times this and this times this are the same, so they cancel out. That's the whole reason we multiply by the conjugate, so the middle terms cancel out. And then minus, I think that was my alarm. Minus this times this is the square root of this times the square root of this, which is just 2x plus 3. Now be careful here. It's minus all of that, so we need some parentheses around it. The bottom is h times all of this, which I'm just going to use a bracket for a second. I'm going to simplify. 2x and 2x cancel. 3 minus 3 cancels. I'm left with 2h over h times all that stuff. I know I'm getting a little lazy at the end. Finally, this h cancels that h. So I'm left with 2 over, I'm going to write it out. I don't have enough room. You get 2 over, right down here. 2 over the square root of 2x plus 2h plus 3 plus the square root of 2x plus 3. This was a kind of hard example, but it does show that the whole goal when you're doing these different quotient things is to make sure to cancel out the h that's on the bottom. So this is something I would say you should know how to do this. You should have seen this in pre-calculus at some point, maybe. Definitely maybe easier examples. So what I would encourage you all to maybe try is to do the same thing for like f of x equal to x squared minus 2x plus, let's just make it x squared minus 3x. And again, if you're trying to take this quantity and simplify it down to where you get to cancel the h out. It's something they will probably talk about in 17A as well, but it's usually a concept that's covered in pre-calculus. But if you want me to do more examples, I can definitely record some more examples later today. I should, yes, definitely, will do. Let me write myself a note. I'll remember. No, I won't. Let me write myself a note. 17A, difference quotient. Okay. All right, you guys. It's been fun. Again, if you have other things you want to see me talk about, it feels weird to be off camera like that. It's been fun. If you have other things you want me to talk about in videos I'm going to make this afternoon, let me know either by email. I feel like email is the best, but if there's another way you want to contact me, feel free. I suppose you could do a discussion as well. That would also be fine. And then other people could see it so they didn't like duplicate someone else's request. But whatever you want is good with me. And yeah, I think that's it. All right, I'm going to end the meeting. I'm going to try to post the video to Canvas as soon as it's available. And we'll do this again on Wednesday. Take care. All right, here comes the end of the meeting. Dun, 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 dun. If I can figure out how. Oh, there it is in red right there. Bye, guys. Take care.